Okay. So short unit, as I promised. We did section 8.3 last time. So real quick, let's review a few things. Perimeter. How do you find the perimeter of anything? Add up all the sides. Beautiful. Let's talk about the perimeter of a circle. How do you find the perimeter of a circle? Pi times r times 2, or 2 pi r, yes. Or pi d, if you want to remember both, because the diameter is twice the radius. Either way. Okay, so far so good? Okay.
If you do pi r times pi r d, you can do it.
No, not pi r d. It's 2 times pi times r. Okay, so that's what I told you in class. Okay, 2 times pi times r, but then we also know that 2 times the radius is the diameter. So, or you can have pi times d. Okay.
I was just wondering because I know the diameter is twice the radius.
But if you don't want to remember both, 2 pi r. Okay, so then area. We talked about the area of a few figures. Area of a triangle. How do you find that? Okay, half base times height. Yes, that's exactly right. Okay, and then trying to remember everything in terms of base times height. So then a parallelogram, meaning a rectangle or a square or a parallelogram. How do you find the area of that? Because it's there's two triangles. So it's base times height. Exactly right. And then a trapezoid. Trapezoid is what? Right, so the average of the bases, which is base 1 plus base 2 divided by 2, that's how you find the average. The average of the bases times the height. And then the other area thing we had was the area of a circle. How do you find the area of a circle? Pi r squared, yes. Okay, so don't get confused. I'm pretty sure you all remember this from arithmetic. These are different things. R squared means r times r. This means r times 2. Okay, so those are different things. All right, so I think that pretty much catches us up to where we were. I think I promised that we would do one more subtraction problem before we got going today, because those tend to be the problems that catch people asleep. So before we get going with today's stuff, let's look at this problem right here. So let's do this. Okay, this is just a problem in the book. So here we go. Okay, decent, not bad for first thing in the morning. So we've got a circle. We're told that the diameter of the circle is 10 meters. And then inside that circle, we are cutting out a rectangle.
You put the rectangle inside the circle?
Yep, we're cutting it out. And we're told that the dimensions of the rectangle, this side is 8 and this side is 6. And so then what we want to find is what's left. So I'm kind of hurriedly coloring it right here. We want to find this area that's left over when I start off with a circle and then I cut out the rectangle. And what's the area that's left over? So we give a couple minutes. This helps us review a couple area formulas. Yes.
This might not be a very fun question, but I was confused with like the area of the triangle. You have to do like the 1/2 times 2 times 5. So then isn't also the Pythagorean theorem the area of the triangle?
Pythagorean theorem is a squared plus b squared is c squared. So you're not finding the area. I had drawn the picture, sorry to confuse you, the area of the squares that you can form with the sides of the triangle is maybe what you're thinking. But the Pythagorean theorem does not have anything to do with the area of the triangle.
It tends that line.
What's that?
The diagonal line.
Yes, that's the diameter of the circle. How are you doing? Good to see you back. Hello. We are finding the area left over. We're starting with a circle, and we punched out a rectangle out of the middle.
Working?
Yeah, that or I got really weak overnight. Whew, I'm exhausted from sharpening this pencil. You're welcome. You saw all the effort. Wow. We're finding the area left over here. We started with a circle, and then we're taking out the rectangle in the middle. I'll give you another minute or two. That pencil breaks, we'll go to another room and sharpen it, okay? All right, so we started with the circle, and we already reviewed all the formulas. So the area of the circle, let me actually make a little, I'll just put a little circle there. So the area of the circle is equal to, you told me a few minutes ago, the area of a circle is pi times r squared. So let's fill in the things that we don't know. I didn't give you good instructions, so I apologize. You're either using your pi key on your calculator or 3.1415. Either way, that'll be good. And then we'll round to the 100th place. So for pi, we're going to use 3.1415, or you're using your pi key. And what's the radius of this circle right here? 5. Okay, the diameter is 10. The diameter is the distance all the way across. And then the radius is half of that. Okay, radius is always half of our diameter. So I'm going to throw this into my calculator, then I'm going to round to the nearest 100th. So I've got 25 times 3.1415, and that turns out to be 78.54. I do have units of meters, so that's meters squared. So far, so good. Anybody get something significantly different that that you're not sure of? So now the area of the rectangle, I'm just going to draw a little rectangle here. The area of the rectangle that I have, and again, you shared with me before, the area of a rectangle or any parallelogram is just base times height. So what are the two measurements I'm going to multiply? What's the base of that rectangle right there? Oh, you know what? Yeah, there it is. It's up there. 8. Well, I didn't write it for a minute. And then what's the height of that rectangle right there? 6. That's great. 6 times 8 or 8 times 6 is 48 meters squared. And then how do I use those two measurements to get the area of the shaded part? You subtract. You start with the circle. That's what we started with. So the area of the whole circle, the whole interior, is 78. I've cut this part out with some scissors. And so now the shaded part is going to be what I get when I take the circle minus the rectangle. And so that's 78.54 minus 48. And so it looks like I have 30.54 meters squared.
You can do pi times the diameter, right?
No,
Okay. 'cause
Not
I
on
think
area.
I have like a really long answer.
not on area,
Okay.
because r squared is not the same as the diameter. 2 times r from the circumference, the outdistance around, is the diameter. That's why you can make that substitution, but this one you have no choice. It has to be r squared. Lovely question. Any other questions before we move on to today's stuff? Okay, just a quick review of area. We went through the formulas. We now look at this example right here, and it's now going away. Goodbye. All right, so our second section in this unit, remember this unit is just 2 sections because there's a bunch of things to remember. And so we're gonna hopefully remember it and then get it out of our system on Thursday, because today's Tuesday. So in 8.4, what we're gonna talk about is 2 quick things. We're gonna talk about volume, and then we'll talk about, to wrap things up, what's called surface area. So now, instead of talking about 2-dimensional figures like the floor or the wall and calculating the area, meaning the flat part of the interior region, when we talk about volume, we're now talking about 3-dimensional figures. And there's 3 types of figures we're going to deal with. I'm just going to go one at a time. And I want to give you the best, hopefully possible way to remember this. So the first type of figure that we're going to deal with the volume of is what's called a prism. Okay, so again, we're going to do 3 basic types of figures to find the volume, meaning the space. So like when we're dealing with volume, we're talking about now the air in the room. Okay, that's volume. It's a 3-dimensional figure. So the first type of thing is a prism. And what a prism is, it has the same figure on the top and the bottom, and then rectangular sides. So for instance, I'm going to do my best here, so forgive me. So the first thing, let's say we have, this would be called a triangular prism. So I have a triangle on top, and then I connect all the sides are rectangles, and then I have another triangle on the bottom, and I'm going to do a dotted line for what we can't see right there, not too shabby. Okay, that's a prism. I've got the same figure on the top and the bottom. It can be anything. And then I've got rectangles for sides. That's a prism. Let me draw another prism. We would call this ordinarily a box. Let's say I have a rectangle on the top and the bottom, or a quadrilateral of some sort. So then I have rectangular sides. And there we go. There's another prism. Okay, so one more time, just hopefully so that we remember it, a prism has the same figure on the top and the bottom, and it has rectangular sides. There's one more thing that's a prism. It gets a different name, but it follows the exact same formula pattern. So we only have one thing to remember here. If the figure on the top and the bottom, instead of being a triangle or a parallelogram or a trapezoid or a pentagon or whatever else, what if I had a circle on the top and the bottom? Does anyone know what a prism with a circle on the top and bottom, what that's called? Yeah, it's called a cylinder. But I'm lumping it into the category of prism because it follows the exact same setup as all these prisms. And so the volume of a prism, so capital V for volume, and then I've just written the word prism so that we know what we're talking about. The volume of a prism always follows this pattern right here. It is the area of the base. Whoops, not the bash. Thinking about the weekend, that'd be fun, going to a bash. Okay, so it's the area of the base times the height of the prism. So the distance between the bases. Now, here's why I'm giving this to you in this way. Now, instead of having to remember a separate volume formula for every single type of prism that I could throw at you, You just have this one volume formula, and then this is the stuff that we did last section. So if your base is a triangle, it's 1/2 base times height of the triangle. If your base is a trapezoid, it's the average of the bases times the height. If your base is a circle, it's pi r squared. Okay, so we already, hopefully, because we've done the homework, if you haven't, please do before Thursday, we already kind of have in our brain this part right here because that's what we did last time. So for instance, here's going to be an example by me. So let's say I have this this triangle right here, this triangular prism, and I know the following. I'm going to give some dimensions right here. Let's say that I know that this side over here is, well, that's terrible. Let's say that I know that this side right here is 12 inches. And then on my triangle, let's say that that is 7 inches. And then from top to bottom on this, let's call that 20 inches. And I want to know the volume. I want to know the interior space. If I was going to fill this up with liquid or oxygen or what, I want to know how much volume is this going to hold. Okay. Just giving you a second to write because I don't want to get ahead of you because I don't think this is too terrible if you're following on, if you're able to follow along. So here we go. The volume of this, since it's a prism, since it has the same figure on the top and the bottom, goes like this. The volume of the prism is the area of the base times the height. Well, my area is my base. What kind of figure is the base? It's a triangle. And the area of a triangle, and you can write less than this if you want when you're doing it, but the area of a triangle is 1/2 the little base of the triangle times the little height of the triangle, and then we'll multiply by the height between the two triangles. So let's plug in the appropriate information. What is the base of the triangle? What's the length of the base of the triangle? 12 inches. Right. What is the height of the triangle? 7 inches. And then what is the height of the prism? Yeah, the height of the prism is this distance between the two bases, so that's 20 inches. So the new bit is this volume of the prism, area of the base times the height. But once you've got that down pat, you just now plug in, hopefully, the things we remember. So I'm trying, again, my goal is I know there's a lot to remember in these two sections, and I'm sorry for that on one level. Okay, but I'm trying to present it to you in a way that we've broken it down so that it's at least a little bit less. Instead of giving you a formula for this and a formula for this and a formula for the other, I've given you a very general formula that you can plug in the stuff you already know, hopefully, into it. Okay, so now it's just a plug and chug. 1/2 times 12 is 6. 6 times 7 is 42. 42 times 20, I think that's 840. And then my units. We're talking about a 3-dimensional figure. Inches times inches times inches. Inches cubed, or I like inches cubed. I'm going to write inches with a little exponent on it. But if you would like to write cubic inches, if that is more your speed, go for it. Okay, that's fine too.
How do we know when to do like inches?
It depends on what you're finding. If you're finding volume, since it's a 3-dimensional figure, since we're talking about the space, it's always going to be a cubic unit. If you're finding area, like we did on the example we started with, which is a 2-dimensional, which is the area on the board, that's squared. If you're finding a length, like a perimeter or a circumference, that is a 1-dimensional unit, and there's no power on it. It's just inches or feet or whatever the units are. Okay, 1, 2, 3-dimensional. All right, so I've left my cylinder up there because I did pretty good drawing it, and I didn't want to test fate here. So here's what I would like you to do. I'm going to give you 2 dimensions. There's the volume of the prism. So I'm going to tell you that the distance across the top of my cylinder here, let's call that 14 meters. And then this from top to bottom on this prism, let's call that 30 meters. Okay, so those are my 2 dimensions. Please find the volume. If this prism was going to hold oil or gas or something, how much would it hold? All right, so the volume of this figure, the volume of any prism, again, I'm repeating this, so hopefully it sinks in. A prism is something that has the same figure on the top and the bottom, and the sides are rectangles. And so the volume of any prism, no matter what the top and the bottom are, and of course, in this class, for us, the top and the bottom, there's a limited number of figures we know how to find the area of. So on the test, I'm not going to put like an octagon or something because we don't know how to find the area of something like that at this point in our math lives. So the volume is the area of the base. What's the area of a circle? How do I find that? Pi r squared, or r squared pi, and then times the height of the prism. So here we go. Pi is 3.1415. R squared, what is the value of R for this prism right here? 7. And we're squaring it. And then what's the height of this prism? What's the distance between the top and the bottom, or the left and the right if it was oriented different? 30. All my units are meters, so that's great. So I've got meters and meters, that's meters squared here, and then another one that's meters cubed. And so at this point, once you get the information in the right place, now it's just to calculate a problem. So you let your thumbs do the work at this point right here. And so what we have is 3.1415 times 49 times 30, and then we'll round to the hundredths place, and we get 4,618.01 meters cubed. If you used your pi key, you're going to have a different decimal here by a little bit. So yeah, I'll take into account. So as long as you're doing the instructions on the test, will say either use 3.1415 or the pi key on your calculator, because I don't know that the little calculators I let you borrow, I think they do. I'll have to look, but I don't know if they have a pi key. And then round to the 100th. Yes.
So when you do the math, do you square the 7 first, or do you multiply the pi by 7 and then square that?
Oh yeah. So the square does not apply to the pi.
Okay.
The squaring is only to the 7. So this right here, that's where when I was multiplying my calculator, that's why I had 49. The 7 squared, I just did that in my head as I was multiplying, as I was writing it down. So yeah, that's order of operations for our, if you remember your arithmetic order of operations, exponents comes before multiplying. So you would do your exponent and then multiply these 3 numbers.
Okay.
Great question. Any other questions? Okay, so when you see something called a prism, same top and bottom or same left and right, if that's the orientation of the picture, you find the area of that base, top and bottom or left and right, and then multiply it times the distance between those. That's the first type of three-dimensional figure that we are finding the volume of. I'm going to present all the figures and we're going to talk about volume, we'll talk about surface area, and then whatever time there's left over, we will use it to do other examples. The second type of thing is in general called a pyramid. So we're going to find the volume of a pyramid. I can only draw pyramids upside down. I don't know why. I am impaired for some reason. If anyone wants to take a stab at it and wants to grab the marker and draw a pyramid right side up, be my guest. So our pyramid has a base, and then all the sides come to a point. So for instance, here is a pyramid with a square as a base, looks something like this, and then all my sides come to a point. Okay, so this is my base. Okay, so if you were in Egypt, it would be the other side, and you'd be looking at it standing up, and then everything comes to a point. Okay, we can do the same thing with a triangle as the bottom. So there's my triangle as the bottom, and everything comes to a point. So again, just like with the prisms, it's called something different mathematically, but it follows the exact same pattern. What is it called if I have a pyramid that has a circle as a base? What is that called? It's called a cone. Yeah. But for our purposes, the cone follows the same pattern to be able to find the volume of it. Okay, so the volume of a pyramid. And in fact, it's almost the same thing. So that's the good news. Instead of being the area of the base times the height, the volume of a pyramid is 1/3 the area of the base times the height. So it's similar to what we just saw.
Is it just 1/3 base times height?
Mm-hmm.
No, you don't have to find area.
Area of the base
Okay.
times the height. I use a capital B and a capital H for our 3 dimensions. So it's the area of the base. So if you need to make a little note for yourself, this is the area of the base. This is the height of the pyramid. So what I'm going to do first, I'll do the cone and then I'll let you do that one. So we'll reverse what we did before. So let's find the volume of this cone. Let me change the dimensions a little bit. Let's say that I've got a diameter of the bottom here. Let's call it 20 millimeters. And then from top to bottom, from the base up to the point, we're going to call that 45 millimeters. And so this one we're going to do together. What's the volume of this pyramid? How much ice cream can I put into this cone? All right, here we go. So the volume of any pyramid is 1/3. That doesn't change. That's the same for every pyramid, including the cone. The area of the base, you've already told me this, but we're going to write it down again because we're practicing. Repetition builds memory. What is the area of the base of this? What's the area of a circle? Pi times r squared, and then times the height of the pyramid, the height of the cone. So it's 1/3. Pi is 3.1415. The radius, what's the radius of my cone right here? 10 millimeters. And then the height of it is 45 millimeters. And then I'm just ready to go to the calculator. Again, so the big challenge of all these, and I'm not saying it's insignificant, it is a challenge. The challenge to all these is remembering where you're putting the information, remembering the formulas, okay? So I've got 10 squared. I'm doing that first to answer the previous question. So 10 squared is 100. So I start with that. And then the order you do the rest of this doesn't matter. So I got 100 times 45, then times 3.1415. And then I'm going to take all of that big number, I'm going to divide it by 3. And I get this. It's already rounded to the 100th. So it's 4,712.25 millimeters cubed. If you got a question about that, please raise it. Let's talk about it. So here I've got this pyramid. I've got, I said at the time I said it was a square, so I'll stick by that. So what I've got here is I've got something with, let's go 11 inches by 11 inches, and then from bottom to top or top to bottom, however you want to look at that, that is 14 inches. So I would please like you to find the volume of that, and then if you end up with a decimal, round to the 100th place, please. Okay, so the volume of any pyramid, and again, a pyramid is something that has one of our shapes as its base, and then all the sides come to a point. All the sides are triangles instead of with a prism, all the sides are rectangles. Okay, so that's what a pyramid is. When you identify that you have a pyramid, the volume is 1/3 the area of the base times the height. In this case, I've got a square. A square is just a parallelogram. And hey, if you remember the formula for a square, it's not super difficult, but if you got it, that's great. But the base is just a parallelogram, so its area is little b times little h, base times height. And the thing for a square is base times height are just the same. So the formula for it is, our book says s squared, side squared, but again, no need for extra formulas. If your brain doesn't take well to formulas, I don't blame you. Mine doesn't either. So that's why I've been trying to give you a way that minimizes the stuff you have to memorize. So here we go. We've got 1/3. The base of the square is 11 inches. The height of the square is 11 inches. And then the big H, the big height of the whole pyramid, is 14 inches. Okay, that's the difficult part of the problem, okay, is remembering and getting the information in the proper place. Once you've done that, the rest is calculator. 14 times 11 times 11, and then we divide that whole thing by 3. And I said, let's round that to the 100th. So that's 564.67, and we've got inches cubed. Anybody got a question, comment, or concern? I'm trying to take this nice and relaxed. I know this is difficult stuff. I know for some of you this is new, first time, or you haven't seen it in a long time. Just want this to go smooth. I want you guys to do amazing on test 4 that you're going to have on Thursday. Okay, I want this to go swimmingly. Yes, yes, 48 hours from now. All right, so we've got the prism, we've got the pyramid. There's only 2 sections on this test. That's why it comes at you fast. And then you'll get some breathing room in the 5th unit. It's a little longer. It's my second favorite unit. Probably the next last 2 units are probably the most applicable units that you'll see and use as you leave this classroom. So it's gonna be good stuff. So the last thing we're gonna find the volume of is called a sphere. What a sphere is, if you remember last time, I defined for you a circle. I told you a circle is the set of all points in a plane that are the same distance from a point called the center. So it was just 2-dimensional. Well, a sphere, you would just change one word in that definition to get a sphere. I'm going to write this down. I'm not going to make you reproduce this definition. I just want you to understand what this is. A sphere is the set of all points in space, and that's the one word that's different. Instead of in a plane, it's in space, that are the same distance from a point called the center. So now we're talking about a 3-dimensional figure. We're talking about, like a basketball or volleyball or whatever, golf ball, whatever kind of sport you like to play or watch or whatever. So I'm going to, again, make my best effort to draw us a sphere. Okay, that's a little lopsided, but it's going to do. And then to give us some perspective, I'll draw an equator around it. Oh, that's lovely. So there's my sphere. So again, if I'm going to fill this up with some sort of liquid or some sort of gas, I want to know what's the volume, what's that interior space like. And so there's no like simple way to say this is like base times height or anything. So I'm just going to throw it at you. The volume of a sphere is always equal to 4/3, 4/3 pi times r cubed. Pi times 4/3 times r cubed. R times r times r. If you don't know how to do cubes in your calculator, I can show you how to do exponents in your calculator. It's nice and take you 2 seconds to let me show you. But if you don't want to do that, then just hit radius, whatever the value is, times itself, hit multiplication. So it's pretty straightforward. It's just a plug and chug problem. So the key here is remembering 4/3 pi r cubed. So here you go. I'm just going to give you this example, and you're going to put the number in, round this to the 100th. For pi, either use the pi key on your calculator or use 3.1415. It absolutely does not matter what. So let's say that this is 9 feet. Okay, 9 feet. Find the volume of the sphere. Yes, round to the 100th, please. So you might be thinking, this is a formula. How do I remember this? Repetition. Do all your homework. If it's still not sinking in, take a 3x5 card. Write volume of a sphere on one side. Write the formula on the other. Quiz yourself. Okay, it takes a little effort, but it'll help you. You'll do great on this test, and then you won't be sorry that you did it when you're looking at a great grade when I get back the test. So the volume of this is 4/3 pi. I'm going to use 3.1415, and then the radius, I gave you the radius, is 9 feet, and we're going to go ahead and cube that. And so once you get the information where it needs to be, this is not really too much of a big deal for a problem. So 9 times 9 times 9 is 729 times 3.1415, and then times 4, and then I'll divide that all by 3, and we end up with 3,053.54 when I round to the nearest hundredth. If you use the pi key, again, as I've said before, your decimal is something close to this, but probably a little bit more. Okay, and that is fine. I will see what you did, and I will be completely happy. Okay, so that's all the figures we have to find the volume of. Now we're going to do a U-turn, and we're just going to go back, and there's 2 figures that of the 3 that we've done that we're going to find the surface area, meaning what's the area of the outside. Yes, what's up? Thank you for making sure I do the problem completely. Yes, my units are feet, and so since it's a volume, it's feet cubed. Yes, thank you. Just so excited to do surface area that I was rushing through the end there. Okay, that's the volume. Those are the 3 things that you are accountable for knowing how to find the volume of. The prism, same base top and bottom, pyramid, a base, and then it comes to a point, and then a sphere. So now we're going to go backwards, and we're going to talk about what's called the surface area. So let's say that instead of filling this sphere up, I was interested in painting it, or I wanted to know how far an ant would go if it was walking around the outside. So I want to know, what is the area of the outside of this? Yes. Okay, so this is a fraction. So what I did in my calculator is I hit the r cubed, then times 3.415, and then I multiplied by 4 since it's in the top. And then a fraction just means division, so then I divided by 3 since it's in the bottom. So always multiply by 4, divide by 3. That's what I did there. Yes. All right, so what if I'm going to do something on the outside? That's called the surface area. I'm just going to use the abbreviation SA. I don't know that our book has one for us, so that's what I'm going to use. And again, there's no easy way to say, okay, this follows some sort of pattern. So I'm just going to go, it's 4 times pi times r squared, the surface area of a sphere. How much paint or how much wrapping paper would I need if I was going to do this on the outside? So what I would like you to do, please, is, okay, we just found the volume. We found how much space is on the inside of the sphere. How much area is on the outside if I was painting it? So please go ahead and plug and chug and find the surface area of that sphere. For the surface area. And then the other thing we're going to find the surface area of, and that will be the end of the new stuff, is of a prism. We're not going to do surface area of a pyramid in this class, just the surface area of a prism. So I'm going to plug and chug. The 4, that's part of the formula. The pi is 3.1415. We're going to use the pi key. And now since I'm finding area, the surface area, I'm just taking the 9 feet. And this time I'm squaring it. Okay, we're not cubing it. This is the area, not volume. Okay, so don't cube, don't use cubic measurements here. So when I do that, oh, I turn my flashlight on for some reason. Oh. All right, so let's try to do the right thing. There we go. So 9 times 9 is 81 times 3.1415, and then times 4. That turns out to be 1017.85. And since it's an area, it's feet squared. Okay, so we got our units because I've been reminded. Yes, it's an area. It's the area. If this was a planet, be a lot bigger, like us walking on the planet. That is an area, but it's round. We're walking on the outside of the sphere. Okay, so a big one. All right, the other thing that we're going to do the surface area of is the surface area of a prism. So I'm going to redraw my triangular prism here that we were using earlier. I don't remember the dimensions of that one, but I'll make up new dimensions. So here's my triangular prism. And let's say, I don't remember, but let's say that this side is 10 inches. And then I think I said the height was something like 7 inches. And then from top to bottom here, this is going to be, let's call this 20 inches. And then I'm just going to label the other sides of the triangle at the bottom just so that I don't create a mess up here at the top. So let's call this one 8 inches, and then this one 9 inches. We'll just keep all the measurements kind of right there. So I'm going to give you a second to draw that prism and to go ahead and label the appropriate things. And then what we're going to do is find the surface area. And so how do we find the surface area of any prism? And that's going to be the thing that I try to impart on you. Okay, so the surface area of a prism. Here's what you're going to do for any prism, whether it's a cylinder, whether there's a triangle on the top and bottom, whether there's a parallelogram or a trapezoid on the top and the bottom. Here's what you're going to do. And it's just a matter of the sides. So what you're going to do is you're going to find the area of the triangle on the top. So you find the area of the base. Let me just write it out instead of using symbols. So what we're going to do is we're going to find the area of the base. Now let me ask you this question. How many triangles are on this prism? One up here, and then yeah, thank you. There's one down at the bottom, right? So there's 2 of them. So we'll then multiply that by 2. And so make a little note to yourself. If you don't see where the 2 came from, maybe put in parentheses up here, top and bottom. Plus, now here's where it's nice. All the sides are just rectangles. How many sides? So we've got the top and the bottom we've counted for. How many sides are there on this prism? There's this one right here that we can see, right? There's this one here that we can see. And then there's the one that's on the other side. If we're in the other room, looking backwards, we can see it from the other room. Okay, so there's 3 sides. So the way I'm going to notate this is you take 2 times the area of your base, whatever the base is, triangle, circle, rectangle, whatever, 2 times the area of the base, plus then you add up all the sides, plus all the sides. Well, because there's going to be a different number of sides depending on the prism. Like if I have, you don't have to draw this, something like this is already in your notes. If I have 4 sides, on my base. So I got 1, 2, and then how many sides are there going to be as I go around this one? 4. Okay, if we knew how to find it, this is going to tax my ability to draw. So let's say that I have let's say I have a hexagon. That's terrible. You get the point. Let's say I have a hexagon up at the top and a hexagon on the bottom. Okay, if I could find the area of that, well, then how many sides do I have around the outside now? Yep, 1, 2, 3, and then the other hexagon is 6, 4, 5, 6 that I can't see. So the number of sides here that I'm going to add up depends on what the base is. Okay, that's why I didn't multiply by anything, or you just gotta keep track of the sides. So here we go. We're going to find the surface area of this prism. We're going to do it together. So the surface area of this prism. First thing I'm going to do is I'm going to find the area of the base. So I'm going to find the area of the triangle. How do I find the area of this triangle right here? Oh, yes, you got that one down, Pat. It's 1/2 the base, which is 10 inches, times the height, which is 7 inches. How many triangles do I have? Okay, so I'm just going to put some parentheses around that. I'll multiply whatever I get there, I'll multiply by 2. Plus, doesn't matter which one we start with. Let's start with this one. Just put a little asterisk right here. We'll start with this one. What are the dimensions of this rectangle? Base times height. What's the dimensions here? Okay, this one has a side of 8. And then what's this side right here? 20. So 8 inches times 20 inches. Plus, I didn't leave myself enough room. I didn't do good with my board management. Let's do this one right here. I'm just going to put a check mark. So what are the dimensions of the side that I put the check mark in? It's a what by what rectangle? 9 by, yep. So 9 inches by 20 inches. Plus, final one, you told me there was 3 sides. There's the side that I can't see. Okay, the side that if I'm facing from the back. So what are the dimensions of that back side of this prism? 10 and 20. Yep. So the surface area of a prism is basically just going around the whole prism and adding up the areas of all the sides. That's it. So
It's not that hard to do.
okay, I wouldn't use the word annoying, but hey, from your perspective,
It takes a long time.
no, I get it. I just mess with it. Yes, I agree with you. It's not that hard. It's just laborious. Okay, it takes some time, and you just got to make sure you've accounted for all the sides. Yes, you're totally right. But again, remember, it all goes back to the stuff we did last time. If you did the homework last time, then you remember we can calculate the area of a triangle, area of these rectangles, base times height of the little rectangles. So you have all the information. It's now just using it in the appropriate way. So now I'm just going to do some multiplying here. 7 times 10 is 70. Half of 70 is 35. Times 2, that turns out to be 70 inches square is the top and the bottom. The asterisk side, 8 times 20 is 160 inches squared. The check mark side is 9 times 20 or 180 inches squared. And then the back side that I can't see is 10 times 20, 200 inches squared. So 70 and 160 is 230, I think. And then 330, 410, that's 610 inches squared if I'm added right, which you should probably check. All right, I've got one more. I'm gonna do one more with you, and that is the surface area of a cylinder, because I just want to make sure the surface area of the cylinder is going to follow this. And then if time allows, I'm going to give you a prism on your own to find the surface area of. That's probably what we'll have time to do. If there's any time left, then we'll figure out another problem. Okay, so the last thing is my cylinder. So here's my cylinder. Whoop, 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 whoop. So let's say I have this. I've got my cylinder, and I'm just going to give us the radius of the top. We're going to call the top 3. It doesn't really matter. Let's call it 3 meters just because I don't feel like writing more. And then from top to bottom, we'll call that 10 meters. So I'm keeping the numbers nice and relaxed. Now I want to find the surface area of this cylinder. So we said earlier, when I had a triangle at the top, I had 3 sides going around. When I had a parallelogram at the top, I had 4 sides going around. When I had a hexagon, there were 6 sides going around. So my cylinder, I've got my area of my bases. My bases are a circle on the top and the bottom. But then the question is, how many rectangles do I have going around? So think about, if you like green beans or corn or whatever your favorite can is. Here's my cylinder. Here's my cylinder. Right, would you agree that looks like a cylinder? More or less. So what I'm going to do is I'm going to peel the label off. And I want to know how many rectangles does it form when I peel the label off my cylinder. So here we go. I peel it, and there it is. How many rectangles is that? It's just 1 rectangle. So herein, we're going to follow this same pattern. 2 times the area of the base, the circle at the top, the circle at the bottom, plus all the sides. There's just 1 side. And when we get there, we'll figure out what the dimensions of this rectangle are. Okay, so let's get started with this. So the surface area of my cylinder, my prism with a circle at the top and the bottom. Well, one more time, just because we're thoroughly reviewing, what's the area of my circle at the top and the bottom? Boom, pi r squared. Yes. So the pi is 3.1415. The radius is 3 meters, and we're squaring it. And then since I have a circle on the top and a circle on the bottom, I'm going to multiply that by 2 because I have 2 circles. Plus, now, so you paid all this money for these very, very high-tech demonstration. So here is my cylinder, right? I'm going to peel it off. Let's just look at so you told me that there was 1 rectangle, right? Area of a rectangle is base times height. So we're going to look at the height first. And what you're going to tell me what is the height according to my figure right here. Okay, so here's my cylinder. I unpeel the label, and I want to know what is the height of the rectangle. So when I undo it, the height of this rectangle is the same thing as what? 10. It's the height of the cylinder, right? Let me do it again, just so everybody can see. Here's my cylinder. One of the dimensions of the rectangle that's formed is the same exact thing as the height of the cylinder. Does that make sense? Okay. So if this is base times height, I'm going to have something times 10. Okay, great. Now the other thing. This one's a little bit harder. My base of my rectangle. I have base written there. So now look at this. Here's my circle at the top. See the circle? Hey everybody, how you doing? Circle at the top. You can't even see me on the video being all cute. All right, here's my cylinder. When I unpeel the label, what is this base? What is it the same thing as? What's that measurement? So when I undo it, okay, this right here, what was this formerly? Not the diameter, but you're getting close. What'd you say? You're getting closer? You got it. Okay, so let me fold it up again. What is this right here? What's the distance around a circle? That's the circumference, right? So the circumference, when I unfold it, this circumference here becomes the distance right here. You see that? How when I curl this up, my base becomes the circumference of the circle. Okay, so my length or my base of this rectangle is the circumference. Remind me, because we're reviewing thoroughly, how do you find the circumference of a circle? Okay, 2 times pi times r. Yes. So my surface area. We already got 2 times the area. We'll multiply that in just a second. So let me just rewrite it for now. So 2 times 3.1415 times 3 meters squared, and then plus, and then I have 2 times pi times r. So 2 times 3.1415. We're just barely on the video screen, times r, and r is 3 meters. And then times 10, because that was already there. So I'm going to just write it below because the people at home won't be able to see it if I write it to the side. So then it's just plug and chug. That's very difficult, I understand. Takes some practice. You're going to have to sort through one, but don't worry, in my math lab, I've got one for you. So that's not going to be too big of a deal. So first, I'm going to find the area of my circle, and then I'll multiply it by 2. So 3 squared is 9. Times 3.1415, then that is 28.27, then I'll multiply it by 2. And so the area of the circles at the top and the bottom are 56.55 meters squared. Then my area of my one rectangle that goes all the way around this is 2 times 3.1415 times 3 times 10, and that is 188.49 meters squared. And last but not least, when I add those 2 things together, I get 245.04 meters squared. In my opinion, of what we've talked about today, the surface area of the cylinder is the toughest thing, but that's my opinion. That might not be your opinion, but I think that's seeing that one of the dimensions of the rectangle is the circumference around. That's kind of the key insight that you have to be able to make. All right, we've got 12 minutes left. Yes, we do. So I'm going to write on the board a box, and I would like you to find the surface area of this box. Okay, so this is a prism with a rectangle as the top and the bottom. And I would like you to find the surface area of this box, please. And so here are the dimensions of the box. I'll keep the numbers nice and relaxed. We'll call this, I'm not even going to put units on it. So this is 4. We'll call this one 6, and we'll call this one 9. Okay, so 4 and 6 and 9. I'm not interested in the volume of this box. I'm interested in the surface area of this box, please. I didn't put units on this one, so it's unitless, just to speed things up a touch. Bless you. All right, so the surface area of this prism, same as the surface area of any prism. With the box, it doesn't matter if your bases are the top and the bottom, or the left and the right, or the front and the back, it all works out the same. So I'm going to just consider my bases the top and the bottom, and then we'll go from there. So my top and my bottom, what's the area of this rectangle at the top? 24. Base times height. 6 times 4 is 24. So 24 is the top and the bottom. So I'm just going to make a note for your notes that this is the top and bottom right here. So if the area of the top is 24, then the bottom is also going to be 24. So we'll multiply that by 2. 2 times 24. Plus. Now I'm not going to take the shortcut of doubling everything because I want to keep with the same pattern we just had previously. But if you saw it, you notice that the left and the right are going to have the same dimensions. The front and the back are going to have the same dimensions. So you can just double things instead of, but I'm just going to start. I'm going to start with this front side right here. I'm going to put an asterisk. So this is the front. What's the area of the front? What are the dimensions of that rectangle right there? Okay, 9 times 6, so 54. Great. So now I'm just going to go around. I'm going to put a check mark right here. This is the right side. What are the dimensions of the right side? Okay, 4 and 9, so that's 36. And then the back that we can't see, what are the dimensions of the back side there? Okay, 9 and 6 again. And like I said, you could have just doubled the front and said front and back, but I'm just trying to, I just don't want to do this in a novel way and have you confused about why we're doing this one differently. And then finally, the left side over here. What are the dimensions of the left side of this? 4 times 9. Yes, 4 times 9, which is 36. And so then at the end of this, I've got 48 plus 54 plus 36 plus 54 plus 36. What do you get when you add all those up? What was that? 228. Do I have confirmation? 228? I've got confirmation. Math by democracy. Beautiful. There we go. All right. So before I let you go, let's just recap because I know today was formula intensive. It's not generally the way I like to do it. So let's start. Volume of a prism in general. What's the volume of any prism? It is the area of the base times the height of the prism. Okay. A pyramid. What's the volume of any pyramid? 1/3 the area of the base times the height. Then we went to spheres. What was the volume of a sphere? Anybody remember that one off the top of your head?
4/3.
Finish up. 4/3 times pi times r cubed. R times r times r. And then we doubled back and we did surface area of 2 things. We did the surface area of a sphere. What's the surface area of a sphere? 4 pi r squared. Yep. And then we finished with the surface area of prisms. And it's basically just make sure you add up the areas of all the sides that you see. And that is that. So let me stop the recording. Goodbye, everybody.